Hello students, in this class I am going to solve question number 1 and 2 from exercise 7.2. You can get the full solution of exercise 7.1 and proof of the theorem 7.2 and 7.3. Their links have been given in the description box. So students, let's start today's class. Our first question is, in an isosceles triangle ABC with AB equals to AC, the bisectors of angle B and angle C intersect each other at O. Join A to O. Show that number 1 OB equals to OC and number 2 AO bisect angle A. Figure is not given, so we have to draw the figure first. ABC is an isosceles triangle in which this side equals to this side given. The bisectors of B and C, the bisector of B is this, the bisector of angle C is this, and they intersect each other at O, that is, this bisector and this bisector meet at O. Now join AO. Given AB equal to AC. Therefore, we can say angle ABC equal to angle ACB, because as we know that angles opposite to equal sides of an isosceles triangle are equal. So since AB equals to AC, according to the theorem 7.2, we can say this angle equal to this angle. Now, which implies half of angle ABC equal to half of angle ACB, which implies angle OBC equal to angle OCB. Since OB and OC are bisectors of angle B and C respectively. So we get in triangle OBC this angle equal to this angle. Therefore, OB must be equal to OC, because according to theorem 7.3 we know that sides opposite to the equal angles opposite to the equal angles are equal. So we completed proof number 1. Again, since we have angle ABC equal to angle ACB, that is half of angle ABC equal to half of angle ACB. Since this line and this line are the bisectors of angle B and angle C respectively, so we can say these angle and these angle are also equal. That is, angle OBA equal to angle OCA, which implies angle OBA equal to angle OCA. Now, in triangles, AOB and AOC, AOB and triangle AOC, we have AB equal to AC, which is given. Number 2, angle OBA equal to OCA, that is this point. We write here proved earlier, and OB equals to OC, which is also proved earlier. That is our first proof. Therefore, triangle AOB congruent to triangle AOC. SAS rule. Since this triangle and this triangle are congruent, then obviously we can say this angle equal to this angle. Therefore, angle OAB equal to angle OAC. That is AO bisects angle A. That's all about the question number 1. Now we will go through question number 2. In triangle ABC, AD is the perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle in which AB equals to AC. Given AD is the perpendicular bisector of BC, AD is the perpendicular bisector of BC, that is BD equal to DC and angle ADB equal to angle ADC, because both the angles are 90 degree. From the given point, that is AD is the perpendicular bisector of BC, we can write two things. The line AD is perpendicular on the line BC, as well as it bisects the side BC. As this line bisects the side BC, so we can say BD equal to DC, and as it is perpendicular on BC, we can write angle ADB equal to angle ADC. Now in triangles ADB and ADC, ADB and ADC, we have BD equal to DC, which is given. Angle ADB equal to angle ADC, which is also given. We have written it earlier, and AD equal to AD, that is common to both the triangles. Therefore, triangle ADB congruent to triangle ADC. Since these two triangles are congruent to each other, therefore angle ABD equal to angle ACD by CPCT. Actually, angle ABD means ABC, that is angle ABC, and angle ACD means angle ACB, that is angle ACB. Therefore, AC equals to AB, or AB equals to AC, as because according to the theorem 7.3, the sides opposite to equal angles are equal. No more today. I wish you all the best.